Okay, this is the very last section in Unit 1. This is on page 12. We're talking about relative motion. So we've investigated some basic types of motion. So A, motion in which the change of position is constant. That is uniform motion. B, motion in which the rate of change of velocity is constant. Uniform means constant. Change of velocity is acceleration. This lesson is going to show us that all motion is relative. In other words, it all depends on your frame of reference. Consider the classic physics situation of two people riding on a railroad car with a third person standing alongside the track. So here we have person A riding on the railroad car. Here we have person B riding on the railroad car. And alongside the track, we have person C who is watching the train go by. The car is moving to the right in uniform motion at 5 meters per second. So we're going to draw a vector that represents 5 meters per second to the east. This velocity is a vector. It has both magnitude, 5, and direction, which is east. So we're going to talk about these three people. We're going to see what each one says about each of the others. So person A looks at person B. Here's what they say. A says that B is stationary. Person B looks back at person A. B says that A is stationary. Person C is alongside on the ground, looks at person A, who is on the train moving at 5 meters per second east. C says that person A is moving east at 5 meters per second. Person A is looking back at person C. Person A says that C is moving west at 5 meters per second. Again, person C looks up at person B. C says that B is moving east with the train at 5 meters per second. Person B looks at person C and says that C is moving west at 5 meters per second. Now in the second scenario, person A is holding a ball in his hand. Here's person B, here's person C. We're on the same train. It is still moving east at 5 meters per second. Person B, looking at the ball, says that the ball is stationary. Person A looks down at the ball in their hand. Person A says the ball is stationary. Now person C, standing on the ground, not riding on the train. Person C says that the ball is moving. East at 5 meters per second. Now at the top of page 13, we still have 3 people. There's person A, there's person B, and here's person C. A and B are on the same train. They are still moving east at 5 meters per second. In this situation, A is going to throw the ball towards person B at 3 meters per second. So what does each person say about the ball? Person A says the ball travels east at 3 meters per second. Person B, the ball is coming towards them, would also say that the ball is moving east at 3 meters per second. Person C, who is standing on the side watching this train go by, says that the ball is traveling east. Okay, that one makes sense. And they see the ball moving at 3 meters per second, and they see the train moving at 5 meters per second. It's moving east at 8 meters per second. This velocity and this velocity, they are moving in the same direction, and we're adding them together. So this ball, according to person C, is moving at 8 meters per second. Person B, we are 3 people situated here again. A and B on the train, C watching from the side. Person B throws the ball towards person A at a constant speed of 5 meters per second. Train is still moving east at 5 meters per second. Person A is observing the ball coming towards them. Person A says the ball travels west at 5 meters per second. Person B is watching the ball fly through the air. Person B says the ball travels west at 5 meters per second. Person C is watching from the side. The train is moving east at 5 meters per second, and the ball is moving in the opposite direction at 5 meters per second. Person C says the ball travels. Person C says the ball is stationary. If you have the time, you can go on YouTube. There is an interesting demonstration of this that Mythbusters did with a truck that had a cannon in the truck bed and a soccer ball. So the short video is available. It's pretty easy to find. The full episode is kind of difficult to find, but it's out there somewhere. You can see this particular situation illustrated. Notice that the people riding on the rail car are always describing the motion as if they were at rest on the earth. The strange descriptions of motion are always from person C, who is in a different frame of reference. Person C is in a different frame of reference. Which frame of reference is right? Usually, we say that the correct frame of reference is the Earth. But in this case, you might not think so. Any experiment that we do on the stationary Earth will work exactly the same on some frame of reference moving in uniform motion with respect to the Earth. Quick example, when you're driving in your car, if you were to, let's say, drop your sunglasses, they are in your same frame of reference, they would appear to be falling straight down. Just as if you were standing on the sidewalk and dropped your sunglasses, they would be falling straight down. And the reason this works is that your car traveling down the highway at a constant speed is in a frame of reference that is in uniform motion with respect to the Earth. That is the end of Unit 1.